Okay, so finally we're going to deduct the marginal density function of y. So similarly, we could apply the definition of the marginal density function, and this is like this. We're going to integrate x. So we just plug the concrete form of joint density of xy, and as for this question, this is much easier than finding out the fx, because the area, it's like I said, it's like a D2 area. We could, in which case a vertical line has intersection of two particular functions. So whenever you move the vertical line, it intersects with the same two functions. So just 1 over y to y, like we did in the last question, in the first question, and we do the integration, and finally we get ln x, and x is from y to 1 over y, and we get ln y over y squared. Oh, as for drawing that, I cut some slack. I just used the MATLAB to find out the. Well, if you wanted to draw the function analytically, we need to find the derivative, the peaks and nadirs, the domain of the domain. It's very easy. Just y is larger than 1. But other thing, it could be lots of things you find out, or there's even the second derivative, lots of things to find out. And in this case, it just the function just go like the. Just goes like this, and there's a peak, and then the function at first is soar, but its peak, the peak is actually about 0.18, and then it plummets. It just go like this. As for verification of this validity, and we just do the integration, ln y dy, and y is from, obviously in this part is 1 to infinity. And well, similar ways, we just we could just do we could go going like this, and goes to 1 ln y d. There's a minor, and ln y minus 1. There is a negative sign. I'm going to change it into like this, and y from into infinity to infinity. Yes, y, just like that, and finally we could get 1. This is 0, and this is obviously this 1. So nothing more to talk. So now we have already finished our verification of the density function of y.